Oh my god.
Huh?
Remember the party last weekend? Well, guess what? I saw Paul walking together with Emily around campus this afternoon. I think they met at the party.
No way! Isn't he together with Chloe? Hey dude, guess what Mary just told me? She saw Paul walking hand in hand with Emily around campus. Whoa, that hot chick he talked to at the party last weekend? Damn, poor Chloe. Hey Sarah, you and Chloe are close, right? I know something that you might want to talk about with her. I heard that her boyfriend Paul is hooking up behind her back with some girl called Emily he flirted with at last weekend's party.
What the hell? What an asshole. I'm gonna tell Chloe right away. Hey bestie, how are you? I have to tell you something about your boyfriend. He is totally cheating on you. He hooked up with Emily. Many people have seen them together. Just wanted to let you know I am here for you. What? You gotta be kidding me! How could he do this to me? I thought he was serious. I'm gonna break up with that jerk.
Boy, that escalated quickly.
Yikes, we have to come back to this situation, and we'll do so later to see how it's resolved. But first, welcome to this week's video. We need to talk about one of the best ways to find out what is true and what is false. How can you filter out the nonsense and fake news that you're exposed to on a daily basis? What I found helpful was to apply what I had learned as a scientist to everyday situations. The terms scientific method and empiricism are heard quite often in educational online videos. They are praised as helpful tools for finding the truth and increasing the body of human knowledge. But I think they are thrown around a bit too often for my taste, especially by people who have probably never applied them in their careers. What is often missing is an explanation of what these terms actually mean and, more importantly, how you should go about implementing them in your everyday life. Simply saying, "You have to ask for evidence," or "be skeptical and require proof," is a good starting point, but not nearly enough. So let's go ahead and see how the scientific method actually works and how you can use it to better understand the world. Let me start by giving you a step-by-step definition. The scientific method generally can be summed up as an iterative process that helps scientists to close in on the truth step by step. First, you start with an observation. Now, scientists usually look at the natural world. The observations they make lead to certain questions about that world. From these questions, scientists develop hypotheses that they need to test. And this is the most critical point and why it's called empiricism. It's because you actually have to test what you claim to be true. The next, most crucial step is to test your hypotheses with experiments that are specifically designed to prove or disprove the hypothesis. In the next step, the data that is collected from the experiments is analyzed and conclusions are drawn. These conclusions refer to the falsity or the truth of the hypothesis, or in some cases, multiple hypotheses. From this knowledge, scientists develop general theories. Theory in this case is not to be taken colloquially. Scientific theories are only accepted after they have gone through a long process of peer review and testing by many people. These theories are then added to all the knowledge we have about a certain topic and can be seen as part of the observations we make. And thus, the cycle starts anew. I will now show you how this concept is applied in science with an example from one of my own past projects, before we apply it to our little game of Chinese whispers from the beginning. Don't worry, I won't go too much into details so everyone can follow. I'll just highlight the important parts. The professor I was working under at one point was interested in the interaction of certain messenger proteins that bind to a receptor on the cell surface of specific cells. There are two different versions of the messengers. Let's call them A and B for simplicity's sake. They varied in their amino acid sequence and thus in their three-dimensional structure. Now we can form some questions to be asked. For example, why do two ligands for the same receptor exist and how do they differ? The hypothesis that my professor came up with was that these proteins had different affinities for the receptor and maybe even bind to it differently and therefore result in different levels of the intracellular response to a ligand binding, meaning that the body could potentially use them in different situations. In order to test this, I performed a number of biochemical, biophysical and cell biological experiments in order to measure the binding of the ligands to the receptor, their affinity for the receptor, and the intensity of the intracellular response. The methods chosen could either prove or disprove the hypothesis. While analyzing the results, I found out that the two ligands do indeed have different affinities to the receptor and induce different levels of the intracellular response. These findings were now added to everything we already knew about these proteins. With this new knowledge, new questions could be asked. For example, in which situations are these proteins produced by the body? What are the physiological implications? How does the structure of the receptor-ligand complex look like? And so on and so forth. And as this cycle is repeated again and again, researchers slowly but surely edge towards how something really works. Negative, in quotation marks, results are also helpful because they too contain information. For example, if the two proteins from my example didn't trigger different responses, it could have led to different questions being asked during the next cycle. Now that we have the basics out of the way, let's go back to our initial conflict. You might rightfully ask, how is any of this helpful? You probably get why scientists work this way, but is this methodology really applicable for things outside the hard sciences? Let's try it out and apply what we learned by starting with the example from the beginning, where a rumor spread and information was distorted along the way. Rumors are a bitch. Everyone who has been on the receiving end of malicious chatter knows exactly what I'm talking about. It is not rare to see someone's relationships or friendships, their reputation, and in extreme cases their life being destroyed after being maligned. But since Chloe studies physics, she knows how to find out the truth. After the initial shock of the news about her boyfriend, she decides to find out what really happened. She tracks the chain of information to get a good picture of what everyone witnessed. What she finds out is that no one but Mary actually saw the two together on campus. In an ideal world, people would not just spread rumors while adding their own twist. But humans are gonna human, I suppose. She also finds out that Paul was talking and potentially flirting with Emily at last weekend's party. This is still not conclusive enough for Chloe though. The observational starting position is: Mary saw Paul walking together with Emily. Some people saw them talking at a party, and the possibility exists that he is cheating, but it might also be harmless. Chloe can now form two working hypotheses. A. Paul is cheating on her with Emily, or B. Paul is not cheating on her and just found a new friend. She now has to find testing methods to prove or disprove either hypothesis. She comes up with the following. She could ask other people who were at the party if they saw anything. Or she could ask some of Emily's or Paul's friends if they know something. She could also follow and observe the two for a while to potentially catch them red-handed, which is a bit creepy if you ask me, but anyways. Or she could just talk to them directly. As you can see, each method alone might not be reliable enough to lead to a conclusive answer, as is often the case in science too. This is especially true when it comes to eyewitnesses and their testimonies. Therefore, choosing multiple methods for testing is the best way to go if you want to cover blind spots and be as sure as possible about the outcome. So instead of just going to Paul, making a scene and breaking up, she decides to keep a cool head and go through with her investigations.
A few moments later.
After a few days, she collected the following. People saw them talking at the party, but nothing more. They were only seen walking on campus without holding hands by Mary. None of their friends say that they are a couple. She finds out that they are both members of a board game group that meets once a month, and she decides to attend the next game night, where she finds out that Emily, who is a really nice person by the way, already is in a relationship and that she and Paul only met there recently. She obviously concludes that Paul is not cheating.
Oh, Paul, I love you.
I love you too, Chloe. And later they married and lived happily ever after. To end this video, I want to look at one last example that is relevant to all of us. We're exposed to many opinions and claims by politicians, media figures, and other influential people. A topic I already talked about in the last video. So let's quickly look at a claim that is heard and read quite often and play fact checker. The claim I want to examine is: poor people are only poor because they are lazy. I'm sure you've heard that one. It basically means that laziness leads to poverty and therefore insinuates that we don't have to do anything against poverty, because it's the poor's own damn fault. Some people will make this claim because of what they have been taught or because of anecdotal evidence. Unfortunately, this is where many people stop the thinking process. Way too often, all the steps to verify get cut out of the information process, because they require time and are hard and they might conflict with our ideology. People want to feel like they have a grip on things, and challenging ourselves requires effort and can be painful. So, let's rather not. Oh, you can forget about that. Oh, we'll do it. The observation seems to be that there are poor people who are lazy, or at least not as hard-working as more well-off people. The hypothesis, as stated before, is poor people are only poor because they are lazy. In order to test this hypothesis, we need to either perform statistical research, or we could look at the research data others have collected. What could we possibly test for to prove or disprove the hypothesis? Here are some suggestions. Who counts as poor? How many people are working but poor? How many people became poor because of circumstances outside of their influence? Luckily for us, there's already research and statistics that can help us answer all these questions. So let's analyze the data and look at the results. The World Bank defines a poor person as someone who has to live off $1.90 or less a day. Well, this is not particularly helpful for us, as I assume most of us are living in Western nations which require a bit more to get by. So let's look at some numbers for the United States. In this table you can see how little a person has to earn in order to count as poor. If we take the typical family of 4, the number is just above 31,000. So if a household that has 4 people only has $31,000 of disposable income a year, they count as poor. Applying the numbers in this table to income statistics reveals that almost 38 million people in the United States are poor, which is about 11-point-something%. Now keep in mind, this number also includes retired people who don't work anymore, as well as children who don't work yet. So you can knock off a couple million people from that number. It is also worth noting that there are over 12 million people who are counted as working poor, meaning they do work, but they don't earn enough to be counted as middle class. Think back to the table I showed you in the beginning, which only leaves a small fraction of people who are not employed and poor, and thus maybe could be called lazy. But let's be real, sometimes stuff happens in life. I don't judge anyone. Another interesting fact is medical debt. This type of debt occurs very often in the United States and is one of the leading causes for personal bankruptcies, meaning that people who are not insured or are underinsured, which is a thing by the way, lose their livelihood, including their house and everything they own, because they cannot pay their medical bills. The number of Americans with medical debt that say it's unlikely they will ever be able to pay their medical debts off is in the millions. And this is just from a 5-minute Google search. In my further research, I found dozens of articles, statistics and papers that all seem to point in the same direction. The vast majority of people that are poor are not poor because they are lazy or sit on their behinds all day. They are poor because they don't get paid enough, they were dealt a bad hand by life, or they're not yet or not anymore able to work. So the hypothesis has to be discarded in this example. If you're interested in learning more about this topic, I'll be releasing a new video on the working poor in the near future, or you could read about it in many online articles about that topic. Congratulations, you made it to the end of the video. I hope it was valuable to you. You're now able to apply scientific thinking to verify claims and filter out all the bullshit. Thanks again for watching. I hope to see you next week.